Hi, everyone. Today we're going to be exploring a non-linear model to study the different predictors of wage, like age, education, and others. And to this, we will be employing some advanced regression techniques, which include polynomial regression, splines, generalized additive models, and logistic regression. Just for background, linear modeling is a mathematical representation of a situation with a constant rate of change. And polynomial modeling is regression analysis where a polynomial instead of a constant rate is used to represent the relationships between the independent variables and the dependent variables. And our aims in this lab is to develop a comprehensive nonlinear model to explore those different predictors of wage. Specifically, we will be exploring polynomial regression models, step function splines, and generalized additive models, among others.
Yeah, and so the data set that we are using, it comprises of a group of 3,000 male workers in Mid-Atlantic region. And we are using polynomial regression mainly to fit the relationship between age and the wage. And by looking at the results, we are using the degree of 4 for the polynomial model. And the wage increases initially and stabilizes at age 30 to 60 and then starts going down at age 60 and above. We also use splines to improve the model's flexibility, where we place the nodes at age 33, 42, and 51 to ensure that we are capturing the meaningful changes in the wage trends. Similar to polynomial model, wage is also increasing and stabilizing at age 35 till 65, and then starts going down. In addition to polynomial model and splines, we are using a generalized additive model to extend regression by incorporating smooth functions for prediction. So in this case, we are looking at how age, years, and education level is affecting the wage. And according to the results that we have, we can see that with increase in age, the wage is also increasing and stabilizing at the same age around 38, and then starts going down at 62. And then for the year starting from 2003 till 2009, the wage has been going up. With education level, there's different levels of education, but it's clear that with high advanced degrees, that's where people have high wages compared to others.
We also use logistic regression model. So we incorporate generative additive models with logistic regression so as to predict the probability of people earning high amounts of wages. And as we can see from the graphs that the graphs tell us that people with advanced degrees tend to earn higher compared to people with high school degrees. So that's one of the results that we were able to obtain. So what are the conclusions? So the first conclusion is that logistic regression models helped us determine what kind of education helps people earn high wages. So as we noted that before, people with advanced degrees tend to earn higher, advanced degrees and college grad, while people with high school education tend to earn lower. Partial dependence plots also tell us that education is the strongest predictor of wages. So education is strongly correlated to people getting wages. And then the polynomial regression models also tell us that wages increase with age up to a certain point, and then it plateaus, and then it starts decreasing. And then the generalized additive models tell us that wage, they help us to allow more flexible and nonlinear relationships between predictors. So it helps us to visualize and see how we can better predict the response variable compared with the explanatory variables. So what is the future work for this study? So this study, we can enhance this study by incorporating more explanatory variables such as job type, region and work experience, because I think these are also good variables that could help determine how much someone earns. We could also explore other models, because in this study we didn't explore every model that could be that could help us determine how much someone earns. So we could explore models such as random forest or gradient boosting models. And we think that those could enhance the predictive accuracy of how much someone earns. We could also combine something called sharply additive explanations with generalized additive models, which could help provide detailed feature importance insights while maintaining interpretability. So that's all for our project, and we'd also like to thank our TA James for providing assistance on both our project report and our poster.
Yeah, shout out to James right there.
And also shout out to our instructor for, just organizing this course and, helping us understand and, learn more about these models and how to implement them in this project.
Thank you guys.
Thank you guys.
Have a good day.
You.